So what we want to do with this exercise is figure out where is the threshold for different cars. So every car that you go, you have to figure out where you're going to brake hard without locking, or where you get into that locking. So for this car, for example, this car has a lot of downforce. So the braking here is going to be way different from a GT car. So here I'm going to brake at 100. What you see in the telemetry is that I have to decrease the brakes very slowly as the speed goes down, because we lose downforce, and the downforce is basically the air pushing the car down, and you want to kind of figure out how much downforce the car has on the higher speeds and how much downforce the car has on the lower speed. So in this case, the Formula 1 is pretty aggressive, which means we can brake very hard, as much as even 100% in some places, and we need to go down to as low as 40% to prevent locking. If I brake with this car the same way I would brake with a GT car, what is going to happen? We're going to brake at 80% and maintain it. So what happened here? This is interesting because we actually were under the limit on initial braking because we had a lot of downforce. But as the downforce went down, because we maintained the brakes, we eventually got over the limit and locked up the tires. So this is an extreme example of downforce cars. If you go to a Formula 3, that difference between how hard you can brake initially and how hard you can brake on lower speeds is going to be way lower because the car has lower downforce. So for example, it goes from 75% to 65%. In this car, on the Formula 1, for example, we go from 80 to 40, at least in iRacing, which makes a bigger difference because of the amount of downforce that this car has on higher speeds. If we use a different car, like the Porsche 911 Cup car, this car has no ABS, no traction control. We're gonna try braking as much as the car is capable of here. Let's see what happens. We actually maintain the brakes pretty hard at around 85-90%, and the car did not lock up, which means the difference in downforce in this car is pretty much, well, it exists, but it's much lower, which means we don't have to take into account that much. So my braking will be pretty much consistent here, and we just need to find that pressure that will not make the car lock up. So here, for example, it's a very common thing to brake like this and feel okay, the car did not lock up, I'm gonna use that braking. But what you want to do really is brake a little bit later, so you can really get very close to that locking pressure, so you can make sure that on a straight line you are braking as much as possible, because at that moment you want to be using 100% of the grip of the car. And again, this may sound like something very basic, but that 100% being guaranteed that you're braking as hard as possible is quite easy on a corner like Monza, like T1. But as soon as you go to other corners where the hard braking part is a little bit shorter, it's easy to be confused and to mix up things between hard braking and cornering. So what we want to do, again, figure out the braking capabilities of the car, make sure that you can really stop the car as much as possible on a straight line. Let's choose a point here for this car, just like we did before. You can see that this car, you can brake pretty much very hard, 85-90% here with no big deal, no problem. This car is very mechanical, so as you can see, on a car that has a lot of mechanical grip like that and does not depend on downforce, there are some factors that will affect the braking capability of the car.